Hello YouTube and welcome to What the Math. In today's Universe Sandbox 2 video, we're going to be taking a look at Saturn and its moons, and we're going to terraform at least one of them. Before we do that though, let's actually talk about this beautiful gas giant and its rings and also its satellites, starting with the name of the Saturn itself. So what is Saturn? Well, if you've never heard of or if you've never done Greek or Roman mythology, Saturn was the agricultural Roman god of, I believe, harvest. It was a god responsible for all of the harvest in Roman Empire. Now, in, I believe, 19th century, John Herschel, he actually suggested that we name everything that we find around Saturn after, basically after Saturn's relatives in Roman mythology. Specifically, those were all so-called Titans, they were giants. And so every satellite, almost every satellite around Saturn is named after some kind of a giant. And these are actually equivalent to Cronus and his brothers in Greek mythology, but specifically this is Roman mythology. So Mimas and Enceladus were actually brothers of Saturn. And the thing is, what happened in the 20th century is that we actually ran out of names. We kept finding so many satellites that we ran out of names to name other satellites. So everything on the outer ridges of Saturn, so all of these other thingies, all of these other satellites that are much smaller actually. So these other objects, they all of them have three specific mythological references depending on how they orbit and what direction they orbit. There are Inuit satellites in the sense that they are named after Inuit giants, basically giants from Inuit mythology. Inuit is the northern people that live in North America, Greenland, I believe there's somewhere in Russia as well. So they do have a lot of giants named, or giant creatures that whose names were borrowed to name these satellites. There's also Gallic gods from Ireland and Scotland. So these some names are Gallic, and also some of them are named after Norse ice giants. So these are like Nordic creatures. I believe I just saw that this is one that's probably the most famous one. Ymir or Ymir is probably one of the more famous Nordic gods, or sorry, Nordic ice giants. And in total, there's quite a lot of satellites that we've already found. We know that currently there are approximately 62 moons that have been recently discovered, and this is very recent, probably last year or so that we found another moon. And only 53 of them actually have names. And about 12 of them that were recently found within the last 2-3 years still have no names, because we're actually starting to run out of names again. And just like you've probably seen in pictures, this gas giant also has a really large collection of rings orbiting around it. So actually all gas giants have rings, but Saturn's are the biggest and the most profound. You can actually see them through the telescope if you ever look into the sky and try to find Saturn. And what you'll notice is compared to Jupiter, a lot of the satellites of Saturn actually do orbit in a close to perfectly circular orbit around it. At least the ones close to it, including the biggest one that we'll be looking at, Titan, and its friend Hyperion. So a lot of these satellites orbit in a close to a circular orbit and actually in the same plane as well. So they're sort of creating their own little system here. That's been developed over billions of years, and it's close to perfect and in shape. The other satellites don't have regular orbits. These are irregular satellites, and they're orbiting in a very eccentric orbit away from the plane of Saturn. And these were probably captured throughout millennia, throughout millions of years, either through collisions with other objects or basically as they were passing by Saturn and just fell into its gravitational influence. Now, interestingly, when it comes to satellites of Saturn, there's really only one that is worth looking at, and it's Titan. Titan actually has something like 98% of the entire mass of all other satellites just in itself. So every other satellite, if you look at it, so this here is 1.83 moons in terms of mass, and it's about 2,500 kilometers in radius. This is actually the second biggest after Ganymede, which is the satellite of Jupiter. And here, everything else is ridiculously tiny compared to it. If you look at even at things like Rhea, which is actually a quite famous, quite popular satellite as well, it's only 660 kilometers, and it's way smaller. So Titan actually has the most of the mass of all satellites, and if it ever comes to terraforming, it's probably the only one that we can actually even attempt to terraform, because everything else here, for the most part, is not very promising, except of course for this one here, Iapetus. We're gonna talk about this in a second, but it's really Titan that we're going to try to terraform today. And let's actually take a look at the major satellites, the most famous satellites of Saturn, starting with this one right here, Mimas. This is actually one of the objects, this is object number 2 that you can actually use to collide with other objects in this game. And let's take a look at Mimas. And welcome to Mimas. This is actually one of the first satellites that was discovered back in 1789, and its size is about 400 kilometers in diameter, or basically 200 or 198 in radius, and it's actually a lot more rugged looking than this. It does have a lot of craters from all of these collisions, from all of these other objects orbiting around Saturn. And it's relatively circular or spherical in shape, and obviously has a bit of a gravitational field, but in terms of terraformity, or being able to terraform, it's not very promising because it's too small. It doesn't really have all the required materials, and it's more of a, it's obviously a planetoid, it's even smaller than Pluto. And so this is just more of a beautiful object orbiting around Saturn than a potential target for terraforming. The next satellite we're going to take a look at is Enceladus. Let's actually go ahead and find it. And it's on the other side of Mimas. So here we go. This is Enceladus. Now this is, it's a little bit bigger. It's at 252 kilometers in radius. But once again, same problem here. It's too small. It's too rugged, too rocky, and just not enough material in it to terraform it. This satellite is interesting because it actually does have a really high albedo. I don't know if it's actually demonstrated in this game. And yes, it is. Look at that. It's albedo of 1. Basically, almost everything that strikes, in terms of sunlight, almost everything that strikes this planetoid, this moon, basically is reflected back into the universe. Most of the light doesn't stick to it, so it's very reflective. But just like Mimas, it's not a very interesting object for our terraforming purposes. Alright, next one. Next one is Tethys, which is a name of a titan from Greek mythology, and this is actually kind of a relatively accurate picture of what it looks like. Now this one is actually interesting. Well, it is a little bit bigger. It's 533 kilometers in radius, but it's very low in density. It's actually the least dense satellite in the solar system. What does that mean? Well, it means that it's not really made of rock. If you look at it, it's okay, not here, not here unfortunately, but it's actually made almost entirely of ice. So this is actually a good source of possible water for Titan. If we ever come to Titan and decide to terraform, this is where the water can come from Tethys. But other than the water on its surface and beneath the surface, this is really just another, I don't want to say that rock, but that's what it is. It's basically an most likely non-terraformable object because of the lack of mass, lack of size, lack of gravity. It's a lot smaller than our moon, and really it's just the water that might be of interest to us. And the other interesting thing about this object is that it's also very reflective as well. It's actually reflecting quite a lot of sunlight, and it's the second most reflective object after the one we just took a look at. So other than that, other than the possibility of having water and just having reflectivity, there's really very little interesting about this object in terms of being a terraforming target, because it's too small for us to terraform, and unfortunately it's a little bit too not massive enough. It's the mass that we need, and it's lacking that particular feature. The next satellite is right here, Dione. In this game it looks really beautiful. If you ever look at the real picture, though, it's not as beautiful as this. This is mostly, I believe, from the atmosphere. Is there? Yeah, they've given this some atmosphere. I don't know if it has this much though, but it probably does have some atmosphere. It's still quite small. It's actually only 562 kilometers in radius, and it's still not massive enough. But it is a potential target for us to take some water from it, take some other materials to terraform Titan. Now, the interesting thing about this satellite is that it has two objects called Trojan objects, basically objects that orbit in a very specific point in comparison to Saturn. So these are called Lagrangian points, and there's actually one right here called Polydeuces and one right here called Helene. Now these 2 points are, if you were to measure the angle between Saturn and Helene, and then Saturn and Polydeuces, and basically Dione here is in the middle, this angle is supposed to give you 60 degrees, because these actually are in a very specific location around Saturn. And these 2 objects, Polydeuces and Helene, they don't actually orbit Saturn, they orbit a little dot, a little point in space around this area right here. It doesn't show it's not really shown well in this game, but basically there's a point right here in the middle where this object Polydeuces is sort of orbiting around it. Now we have these points around our planetary orbital path as well, and they're actually quite well known. There's actually satellites that have used these points to basically stay around this particular area around the orbit of our planet Earth. But other than that, it's just an interesting fact that these are actually very interesting orbits. They're not orbiting around Saturn, they're really orbiting around this point right there. But really, other than that, and other than the fact that there's a bit of an atmosphere, we know that there's even some oxygen in the atmosphere, but very, 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 very little. Cassini probe in 2010 actually did discover some oxygen in the atmosphere of Dione, but it's just not enough for us to, to breathe. But we can obviously take some of it and bring it to Titan. So this was Dione, and the next satellite is Rhea. And Rhea is right here. It's a little bit bigger at 764 kilometers in radius, and also a little bit more massive, but still not massive enough. And this is Rhea, and it's actually very similar to Dione as well. And just like Dione, it also has a bit of oxygen in its atmosphere. There's a little bit of atmosphere here. You can actually see the thin blue layer right there. But the interesting part is that this particular terrestrial object, or terrestrial planet as it's called here, but it's actually a satellite, is about 75% ice water. And there's a speculation that there might be even liquid ice inside the planet because of the pressure that would be exerted on it from the upper surface or upper area. Basically, you would have such a high pressure inside this object that there might be liquid water inside, which also might suggest that there might be a possibility of life here. But these are all, of course, speculations, and we will not be able to discover any of this until many, many, many years in the future. So Rhea is an interesting satellite and a potential target for us to go and explore and find some water, but unfortunately not enough for us to terraform. And before we take a look at Titan, let's actually take a look at 2 more satellites that are a little bit farther away from Saturn. There's one called Hyperion, which is it doesn't really look the same as it does in real life here, but it's basically known to have a very unusual sponge-like shape, and it's actually not very spherical due to its little size. So this would be a very sponge-like satellite, and really there's very little we know about it because of its small size, but it's interesting because of its very circular kind of orbit, just after Titan. And then we have another one further away called Iapetus. And this one is even more interesting because it is quite large actually. It's 736 kilometers in radius, and also mostly ice, and also very interesting in its composition. But once again, it's not actually spherical. It's been called a walnut-shaped satellite of Saturn because it does have kind of a walnut shape here. And it does have a lot of really interesting colorization, which unfortunately is not really presented well in this game. But basically, it does have a really kind of a large brown, dark brown spot right here, with a lot of white here, and then there's sometimes there is a lot of green coming out of different areas as well, because of the various kind of sublimation of ice from underneath its surfaces that change its color surface. Anyway, so basically, oh yeah, the interesting part about this as well is that due to its kind of a strange, unusual orbit, it's probably one of the best satellites to observe Saturn from. You'll actually see both Saturn and all of its rings at the same time, and it probably creates quite a beautiful view. And the Saturn from this satellite would look about 4 times bigger than the moon from our planet. Anyway, let's get on with it and look at Titan. So this is Titan. Now this is the second biggest satellite in our solar system. It's 2,500 kilometers and it's only about 1.83 times the mass of Moon, so it's not actually that massive, but it is a very interesting satellite to take a look at, and we're actually going to be terraforming this beautiful satellite, this beautiful planet, terrestrial planet. Now, interesting fact about this as I start terraforming it. Actually, let's actually change this. We're not gonna be able to terraform it from this simulation because there's no sun here. We're going to change this to, we're gonna change it to this one right here, all planets and all moons, and this will give us 8 planets with their moons, which we're actually going to take care of these guys because we don't need them, and Jupiter because we've done this in a previous video, and also these smaller planets here because they're not really necessary for us. We're going to erase them and just keep Saturn and its satellites orbiting around it. So basically this is going to be our playground. Saturn, its satellites, look at how beautiful they orbit around each other, and essentially we're going to be taking a look at Titan. Now for this simulation I'm also going to enable tidal heating and tidal evolution because these are important and they do create extra heat and extra warmth for these satellites. But it's Titan that we're going to be taking a look at, which is right here. So this is Titan, and the most interesting thing about Titan is, of course, its atmosphere. It's really the only other object except for Earth that has such a dense atmosphere in our solar system. Its atmospheric pressure is about 1.5 or maybe like 1.45 times the atmosphere on our planet. So it is quite dense. You could actually, I mean, you're not going to like explode or anything if you stand on the planet. It's just, the problem is it's just really cold on it. And also, it's not actually simulated well in this game, but we would not be able to see the surface of Titan. We actually don't even know what it looks like because the atmosphere creates this kind of a orange haze, which you can see right here, and it blocks everything. It blocks the surface. So we know there's like ice and there's like liquid underneath it. When we, some of the probes were able to see this, but we don't really know the actual features of this body. And so what we need to do is we need to start thinking about how to terraform this. Oh, and I did mention that there's liquid on this satellite, and the liquid is actually not water. What it is, it's really interesting. It's actually methane. It's liquid methane that creates these beautiful lakes, beautiful oceans, beautiful rivers on this satellite. So this is something that would be really interesting to see, but I don't think we'll be able to survive in the liquid methane because it's just really cold. And the temperature that you see here is not actually far off from the reality. It's about minus 180 degrees Celsius. So yes, this is a very cold place. Despite its thick atmosphere, unfortunately, it's not able to hold on to the heat from the sun, which is actually really far away from us. Let's actually find it. Where is the sun? There it is. The sun is really far. It's very tiny, so it doesn't provide enough warmth for us. And because we're so far away from Saturn, we don't get enough tidal effect either. So the warmth and the heat here is a problem. And so how do we make this planet warmer? Well, for one, we may want to start using the methane, which is actually a known greenhouse, to basically extract as much of it as possible. We're going to try to melt it and increase our greenhouse effect, increase our atmosphere, and also at the same time possibly decrease our albedo. Well, albedo is actually already pretty low, so that's not going to help us. So we just need to start releasing more greenhouse gases to warm up the planet. And just to simulate this a little bit more accurately, I just changed the silicates here into water just to give it some more ice. Now, interestingly, and this is something that you may have not known before, this is actually the second moon or the second satellite in our solar system where we've actually landed. We actually do have an actual probe that landed here. I believe it was in 2006 or 2007 actually, no, 2007. And this was a Huygens probe from Cassini-Huygens mission, which mapped this satellite first, but then actually landed on it as well. And we do have like a picture from the surface, and now I'm gonna add it right here. This is basically what it looks like. It's sort of like an orangey, hazy looking picture that looks like something from 19th century, but it's really, this is what the surface of Titan looks like. And what you see here is really interesting. So the liquid on this satellite is methane. There's actually rivers and lakes here that the probe did detect when it was descending through the atmosphere. but it was actually methane. And what you see, the rocks that you see, this is actually ice. So the water on this planet is ice. It's rocks, it's the hard stuff, whereas the liquid is really methane. Now, if we were to melt this methane, we could possibly release a lot of greenhouse effect. And I'm having trouble with that actually. I'm trying to increase the atmosphere, but for some reason the greenhouse is not going up. I'm not sure why. Possibly another feature that has been recently added in the game that I wasn't aware of. Used to be that as you add surface pressure, the greenhouse effect would go up as well, as it should. For some reason it stopped doing that. I'm gonna try to figure this out, but meanwhile let's actually talk a little bit more about Titan. So there's actually quite a lot of theories behind possible life on Titan, but not organic life as we know it, even though there's quite a lot of organic materials here. But it's very possible that there's some kind of a methane-based life, because since it does have liquid methane, why not have liquid methane life, right? And so if we do terraform this planet, there's a slight chance we might actually cause massive extinction of that methane life. But we shall think about that later. Let's terraform it first, think about extinction later. We'll keep that life in hidden pockets of methane somewhere. So why is this not increasing greenhouse effect? What happened with the version 14.1? The new version seems to make it more difficult for me to increase the temperature, even though I can actually do this manually, which is really interesting. Alright, so looks like version 14.1 made it much more difficult to terraform things, because now for some unknown reason the greenhouse effect is not going up, no matter how much I increase my surface pressure, and I'll show you in a second. Here, I can actually make this like 600 atmospheres, and look, nothing. Greenhouse effect, the maximum it can go to is really 16 degrees Celsius. This is kind of possibly a bug, I'm not entirely sure, unless I'm missing something, a button that was added very recently, but it's supposed to increase my greenhouse effect, but it's not. So instead, this is what we're gonna do. We're going to use another feature. Actually, let's change this back to, what was it, 2 atmosphere. We're going to use another feature to terraform this. Well, actually, first, let's re-add everything that was removed. I actually did reset the simulation just because I thought it was a bug, but it's not a bug. It is a feature that is not working. So we're gonna make this into a liquidy looking planet, so there's actually probably a little bit more of ice on it. And let's just add some organics to it, hydrogen, just for fun. And now, hey, what's happening to my hydrogen? Where is it going? Hey, come back here, hydrogen. Oh, it's escaping, I think. Alright, fine. Escape if you want. And so what we're going to use instead is, of course, the tidal heating. We're going to try to terraform Titan by, yes, you guessed it, changing its orbit around Saturn. I'm going to basically move it closer. Now, if you move it really close to Saturn, like, let's just say a couple of 100,000 kilometers, what will happen? The planet will start heating up and then eventually start melting. It will actually become really hot and will be melted from inside out. So we need to find just the right distance. And this is obviously us changing orbit with our super awesome technology of the future, where we can basically either use possibly a collision with one of these other bodies. And if you basically smack the asteroid in this, no, wait. Where's the orbit? Here we go. If you smack the asteroid and or object right into this point right here, it will actually slow down Titan. And if you do this at the right moment, you can actually decrease its periapsis, and then at periapsis decreases apoapsis by smacking something into it again, and thus decrease its orbit. Now this will require 2 collisions in a very specific controlled manner. And we can actually possibly even simulate this by doing, let's, what can we smack into Titan? Let's smack Mimas, why not? Because Mimas is already here. Let's smack Mimas right in here, ba-boink. And here we go. This should technically decrease, I'm going to erase these fragments. So this should technically decrease our orbit. Now let's see how we're doing now. Where are we going to be orbiting? It's kind of hard to say because we're basically so far away from Saturn. But yes, this will most likely change our orbit a little bit. Oh wait, I smacked it into the wrong direction. I actually increased the orbit. Oh no, that's not what I wanted at all. That's the opposite of what I wanted. Anyway, so this is the idea where basically you change the semi-major axis by adjusting the, by smacking objects into it and adjusting the orbit. So let's change this to, let's start with 90,000 kilometers. Sorry, 900,000 kilometers. So this is a distance of 900,000 kilometers from Saturn. So we're a little bit closer. And let's see, and now we have a big hole in there too. Let's see if this is going to warm us up a little bit. So here the tidal power is still not high enough, so we can actually go ahead and decrease the orbit again. And this time we're going to go down to 700,000. And we're a little bit closer to Saturn. You can see it a little bit better in the sky now. And let's look at our temperature. And still not hot enough. A little bit closer, let's go to 500,000. 500,000 kilometers away from Saturn. A little bit bigger in the sky. And look at that, tidal power has increased dramatically. So let's actually wait and see. Alright, and 500,000 is also not high enough. So the tidal power is still below radiative power, which is the power from the sun. So we're going to go ahead and move a little bit closer. 300,000 kilometers away from Saturn. This is a distance of Earth from the moon, or moon from Earth. So basically now Saturn is a lot larger, and look at the tidal power. Radiative power, the power from the sun, is actually much less now than the power from the tides from Saturn. Now this will obviously create some deadly tides on this satellite, but we have to live with that because we need some warmth, we need some heat. And the little hole here from my collision with my from Mimas was unfortunately not really successful either. It didn't actually do anything for us. Alright, so let's wait. Look at that. Effective temperature is already going down. So it is very likely that this might actually warm up our satellite and make it habitable. Alright, looks like that's still not close enough. We're currently at minus 140 degrees Celsius. That's still quite cold. Let's move closer. Let's move to the distance of 250,000 kilometers. And the tidal power has increased dramatically, and so did the effective temperature. So let's actually see if this warms us up a little bit. We're gonna wait and see. We're gonna wait and see if this is going to be enough for us to warm up our beautiful new home of Titan. And just like that, slowly, step by step, it started to warm up. It's already at minus 23 degrees Celsius, and currently has started to acquire some clouds from the water vapor. So basically this is where the methane clouds would probably dissipate, and you'll start getting the water clouds instead. Interestingly though, this will obviously change the planet dramatically. So like I said before, if there was actually any methane life on it, it will probably just die now, unfortunately. But we're trying to create this world habitable to humans and Earth life, so we will need to change the temperature for that reason. Unfortunately, this of course will destroy any kind of ecology it might have had with the methane and all other liquid carbohydrates. Alright, so we're getting close there. So there's a temperature of minus 24 degrees, and it's all just from tidal heating. So this means that the tides on this satellite are going to be crazy. This is like, really think about what you saw in Interstellar, those waves that are gigantic, and this is what probably will happen here as well. But this might be like a fun surfing world for surfing fanatics and stuff. Or you can just have very little water so that the tides are not too deadly. And of course tides will also affect things like volcanoes, and there will be more earthquakes, volcanic activity. But this might be fun. Some people might be into the extremeness of this planet, or the satellite, so they might enjoy living here. Alright, so the temperature is still not there yet, but we're getting closer to that mark of liquid water. So we're slowly approaching the melting point of water. And we just passed the 0 degrees Celsius, so that means that liquid water will start appearing any second now. And it has now officially almost become a terrestrial planet, a habitable world for the human race. All this was from changing its orbit, so basically you don't even have to change the atmospheric composition of Titan if you could change its orbit. Obviously it sounds a lot more difficult than it really is. Changing orbits is something that we're not really good at doing yet, but there is obviously quite a lot of things you can do, such as smacking things into objects and changing its orbit that way. Obviously a lot easier would be something like increasing the greenhouse effect, but unfortunately for some reason version 14.1 doesn't seem to work that well. Maybe I'm doing something wrong, maybe there was a button that was added that I'm not seeing, but unfortunately it's not really working right now. So instead we decided to change its orbit, moving it a lot closer to Saturn at a distance of 250,000 kilometers, and the result of this is going to be in front of your eyes in a few seconds. And the result of this is, of course, the beautiful liquid water on the surface of Titan. Now unfortunately it still kind of looks a little bit too rugged because it's still kind of gray and it's still kind of covered with asteroid debris, but nothing we can do about this yet. I think in time, if we were to run this simulation for millions of years, it would maybe change, but right now it is a good start. So this is a habitable rocky world that we can use to surf and to live on in extreme conditions, very similar to, I guess, Hawaii, except more extreme. And so here we have really high tides, mostly because it's so close to Saturn, but at the same time really good temperature, and it's actually going to get to about 23 degrees in a few more years. But the problem, of course, is the tides. When it was in the original spot, it really didn't have that much tidal effect from Saturn, but at this point it's actually high enough for it to be warmed up from the inside, and it's much higher in terms of energy that it creates than even the sun that it gets from this, the energy that it gets from the sun. But other than that, here we go. This is our completely terraformed Titan orbiting around Saturn. Now, unfortunately, the other satellites of Saturn are not big enough, and Titan itself, like I mentioned before, is about 98% of the entire mass of all of the other satellites, including the rings. So most of the mass of objects orbiting around Saturn are in Titan. So this is basically the most massive object here. Other objects are not massive enough for us to even try to terraform, but we can steal some of their water and some of the other stuff from them and bring it to Titan so that we can actually have a really comfortable life here. Other than that, I think I'm going to pause this here, and because this is really the only satellite I was planning to terraform around Saturn, my mission here is complete. Now, thank you for watching. Please subscribe. If you've enjoyed this video, leave a like and leave a comment. And check out some of the other videos I've posted about Universe Sandbox or the universe in general. Thank you for watching, and game you later. Bye bye.